requirements for electrical operation of the points. An automobile on road is guided towards the desired direction by means of a steering wheel mechanism. However, this is not feasible in case of rail vehicles, as rails guide their movement. During train operations, it is important to give precedence or allow crossing. These are achieved by means of points and crossings. Rail is a tapered, movable rail which is attached at or near to one end of a running rail made of high carbon or manganese steel to withstand wear. A tongue rail is also called as switch rail. Rail is a running rail to which a tongue rail operates. The end of the tongue rail is called toe of tongue rail. Power is provided to maintain the two tongue rails at their exact distance. Stock rail joint is the first joint of the stock rail which connects other stock rail in front of points. Stock rail joint is taken as reference for measurement of the points and also for counting sleeper numbers. These are provided under the tongue rails to provide smooth lateral movement of tongue rails. Chair plates require cleaning and lubrication at regular intervals. Tie plates of 12 mm thickness for broad gauge and 10 mm thickness for meter gauge made out of steel flats are provided over the sleepers directly under the toe of the switches and under the nose of crossing to ensure exact gauge at these important locations. The heel joint joins the heel of tongue rail to stock rail with a pair of fish plates and bolts, with a heel block pair of fish plates. Crossing. This is a device introduced at the junction where two rails cross to permit the wheel flange of a railway vehicle to pass from one track to another track. Nose. In a crossing, two rails are machined to form a nose. Check rail. This is a guide rail to arrest the lateral movement of vehicles. It guides the wheels into the required path on turnouts. Wing rail. The two bent-up rails of the crossing which are connected to the ends of crossing are called as wing rails. Position. When the facing point allows movement without diversion, the point is said to be in normal position. Position. When facing point allows the movement of vehicles onto a diversion, the point is said to be in reverse position. Trailing point. Points are facing or trailing in accordance with the direction of train or vehicle movement over them. Points are said to be facing when their operation allows a train to be diverted from the line on which it is running. Crossover. A crossover has points at both ends which allow movement from one line to another when the points are set in reverse. When points in crossover are set to normal position, diversion of movement is not possible. This is an arrangement of points and crossings with lead rails by means of which rolling stock may be diverted from one track to another track in facing direction. According to the direction of movement of trains, the turnouts are classified under two types: left-hand turnout, right-hand turnout. Trailing switch or trap point. This is a single switch point provided on offside of the yard and is used as a mean for isolation. Is formed when two tracks cross each other without any connection, permitting only a straight movement. Slip. In a diamond crossing, when rails are added between the outer crossing, movement around one of the corners is known as single slip. Slip. In a diamond crossing, when rails are added between the outer crossing, movement around one of the corners on both sides of the diamond crossing is called double slip. Crossover is said to be formed when two crossovers overlap each other, preferably exactly opposite to each other. Creep is defined as the longitudinal movement of rail with respect to the sleeper. Creep anchor. A creep anchor is provided between the stock rail and tongue rail to minimize to and fro movement of tongue rails. Creep and level pillar. Creep and level pillar are provided by the engineering department near stock rail joint to measure creep of rails. The level pillar indicates the height of rail level when points are sunk. Gauge. This is the distance between two gauge faces of both the rails that form a track. For broad gauge, this is 1676 millimeters. For meter gauge, this is 1000 millimeter, and for narrow gauge, this is 762 millimeter. Opening of tongue rail. This is the gap measured between the stock rail and respective tongue rail at the toe of the tongue rail. For broad gauge, this is 115 millimeter, and for meter gauge, this is 100 millimeter. Points and crossings is shown on the screen.
Signals. The engineering department provides points that are utilized in signaling systems for safe and efficient operation of trains.
During train operation, it is important to give precedence or allow crossing of trains. These are achieved by means of points and crossings. Points and crossings allow change in track setting or line setting. This is interference to safety of train movements over the track. Before allowing any train movement over the point, proper setting and locking of the points is to be ensured. For this, points are connected to a signal system by means of an arrangement called interlocking. Action. The terms associated with points connected in signaling system are point movement. That is, point movement refers to movement of points from one position to another. Point locking. Locking of points in the last operated position to avoid any unintended movement. Point detection. Detection refers to continuous monitoring of a point with respect to its proper position, and locking, which is utilized for clearing the signal. Click the items on the menu bar to learn route of a train at a station. The points in the route have to be moved in the desired position, that is, normal to reverse or N to R, reverse to normal or R to N. Movement of train over a point causes vibration of switch rails, which may displace from the last operated position, causing a gap between the stock rail and switch rail. Such a gap may result in derailment of train or a train taking two routes. To avoid these situations, point has to be firmly locked on its last operated position before allowing a train to pass over it. It is necessary that the points in the route lie correctly in the desired position and are also locked in that position. This is achieved by means of point detection. Detector contacts break when point is neither in normal nor reverse and in unlocked condition. Points can be moved from normal to reverse and vice versa locally by means of mechanical or electrical methods. During mechanical operations, levers are grouped and connected by rods. In electrical operation, points are operated with a device called as electrical point machine. To get a brief overview of the above methods, click the items in the menu bar. In mechanical operation, point is operated and locked separately with levers through rigid connections by rod transmission. Point detection is done in series with signal wire transmission. The range of operation through lever is 460 meters only. Hence, this method is not suitable for long-range operations. Mechanical point operation can be overcome by means of electrical operation methods. Electrical operation is achieved by means of approved types of point machines which carry out all the functions of point moving, locking and detection, unlike separate operations in mechanical method. Approved types of point machine. The following types of point machines are functioning in Indian Railways. These are IRS rotary type point machine, Siemens 3-phase electric point machine, Sundaram Clayton LM55 point machine, IRS clamp lock type point machine, and GRS type point machine. IRS rotary type point machine is the commonly used point machine in Indian Railways. Siemens DC electric point machine is also available in very large numbers. Operation. 3 conductors are required. The first conductor for normal operation, the second conductor for reverse operation, and the third as common conductor. Long sleepers. In the point zone, the third and fourth sleepers from stock rail joint must be provided longer than the other sleepers to facilitate fixing of point machine. To ensure safety, the track gauge at a point has to be maintained properly. Further, the position of point machine with respect to running gauge is also fixed. These requirements are complied by means of gauge tie plate, which is insulated to allow track circuit to function in the point zone. Track circuit. Point zone is track circuited to achieve track locking. For track circuiting, gauge tie plate, Williams stretchers, point rods, that is, detector rods, lock rods, throw rods, and P brackets on both switches are to be insulated to avoid short circuiting and leakage of battery. Locking. Track locking prevents operation of points when a train is standing or passing over it. Indication locking maintains correspondence between operating mechanism or lever and point machine. When a lever is operated from normal to reverse, it will get locked at D position. Only when the point is completely set in reverse position and RWKR is up, lever locked at D will be released and it can go to reverse position. Thus, the correspondence, that is, point reverse at sight and lever reversed in the cabin, is proved. Similarly, for normal operation also. A separate cable is required for operation and detection of points. A 10 volts DC battery set with battery charges are provided for point operation. For point detection and controlling, 60 volts or 24 volts battery sets with battery charges are used. 24 volts with Q series relays and 60 volts with K50 or metal to relays. Introduction of point machine. The point machine performs moving, locking and detection of switches in single unit by converting rotary motion into linear motion. The advanced point machines work with electrical energy of 110 volt DC and working current of 2.5 amperes. The point machines have the facility of a hand crank arrangement to operate the points manually and a friction clutch arrangement to protect the points from overloading or obstruction. The important difference between the earlier point machines and present-day point machines is that the earlier types of point machines have separate point operation, detection, and locking arrangement of point machine. The electrical point machines are divided into two categories. These are separate type point machine and combined type point machine. Point machine are operated by power. The locking of points is achieved by mechanical arrangement by facing point lock externally. The detection of point is achieved by electrical detector. Separate type point machines are obsolete now. Type point machine. The combined type point machine operates points by power. In a combined type point machine, locking and detection of points is within the point machine. Depending upon the movement of the lock, the point machine is further classified into four types. These are in and out type, straight through type, rotary type, clamp lock type. The in and out type is one where the locking plunger moves in one direction for unlocking and again in the opposite direction for locking during any one operation of the machine, namely from normal to reverse or vice versa. Through type. A straight through movement is one where the locking plunger moves straight through and does not change its direction of movement for unlocking and locking during any one operation of the machine, namely from normal to reverse or vice versa. Type. In a rotary type, the locking segment rotates in clockwise or anti-clockwise for unlocking of the points and anti-clockwise or clockwise for locking the points for normal to reverse and vice versa. Lock type. In and out type, straight through type and rotary type of locking, the stock rail is not detected. Hence, clamp lock type is introduced where switch rail and stock rail is held and detected to ensure that there is no gap between stock rail and switch rail. Main features in IRS rotary type point machine. The IRS electric point machine is a high thrust and rotary type having 2 lock slides and 2 detection slides for independent locking and detection of switches. It has a thrust of 700 kg and can operate all types of turnouts. It works on 110 volts DC. IRS rotary type point machine meets IRS S24 standards. Rotary type point machine consists of the following parts: housing, transmission assembly, contact assembly, electric motor, reduction gearbox, point throw slide, point lock slides, point detector slides, crank handle cutout switch, crank handle. Views: top view, isometric view 1, isometric view 2. Move the mouse over point machine and click the part for more information. Housing. The housing encloses the point machine and is made of cast iron base with a lockable sheet metal cover fitted with rubber gasket for weatherproofing. The base also provides mounting for point machine assembly. Of the following parts: drive disc, segmental lock pawl, pinion, main gear rim, lift out disc, control disc. The main gear rim and friction clutch assembly drives the drive disc. The drive disc is moved by the clutch spring locking plate left hand and right hand, which transmit rotary motion to the main shaft. It has two stud pins for holding the locking member that help to lock the control rim with the drive disc. The transmission assembly is mounted inside the main cast iron body with bush bearings at its ends. Thus, the shaft gets its rotary motion from the main gear rim. Locks the point switch lock slide and point throw slide. The segmental lock pole is normally engaged in the circular lock notches of the point throw rod and switch lock slides. The pinion has 6 teeth which are allowed to engage the rack of throw rod, having 5 teeth in the middle during operation after unlocking for transmitting a linear stroke of 143 mm to throw the point. The main gear rim has 92 teeth and is directly meshed to the motor pinion, having 12 teeth. It gets the rotary motion from the motor and is restricted to 270 degrees. The gear rim transmits the rotary motion to its center shaft through spring-loaded friction clutch, which in turn imparts a maximum of 143 mm linear motion to the throw rod. Lift-out disc is placed between gear rim and control rim and used to actuate the detection and control contacts. It is having a smooth cam 158 mm at its periphery, in which the detection contact actuating pin roller A is allowed to drop when the point is fully locked in normal or reverse position. Similarly, the roller A is pushed upwards once the lift-out disc starts its motion for unlocking of the point. The motion of the main gear rim is first transmitted only to this disc. The control disc is used to lock the detector and control contact actuating the pin roller A in its home. For this purpose, a small cam arrangement is provided in its periphery for 120 mm and the moving roller A is allowed to drop into this cam at the end of the rotary motion. The design of the cam is such that it cannot actuate the roller upwards, but it locks the roller and gives more reliability to the detection contacts. Control disc gets its movement from driving disc pins through locking member to control disc pins. Inside the main gears of the following parts: slip ring, compression spring assembly. The compression spring assembly is inserted in the slip ring. The complete assembly is fitted inside the main gear rim and held in position by means of left hand and right hand spring locking plates. The spring load on the top slip ring can be increased or decreased by tightening or loosening the adjustable bolt provided in its assembly, and this increases or decreases the frictional load on the main gear rim. Since it is pre-adjusted by the manufacturer, there is no need to adjust at site. Motor. The electric motor converts electrical energy into mechanical energy and operates points from normal to reverse and reverse to normal directions. Specifications of electric motor. Specifications of electrical motor are: rated voltage should be 110 volts DC, capable of working at plus minus 25% of rated voltage, RPM of 1700 plus minus 15%, rated currents 5.3 amperes and maximum 8.5 ampere, operating time of 4 to 5 seconds, power is 440 watts or HP of 0.59, gear oil used is SAE 30 and rating 10 minutes. Reduction gearbox. The reduction gear ratio is 20.8:1. The machine is provided with 3-stage reduction gear. The reduction gear box houses 2-stage reduction gears housed with sealed motor and immersed in lubricating oil. In the third stage of reduction, the pinion engages with the main gear rim. Point throw slide. The throw slide has a hole at its end and a rack in the middle in which the pinion engages after unlocking and gets a maximum stroke of 143 mm for driving the point switch rails from normal to reverse and vice versa. Further, it has 2 lock notches for locking the throw rod at the end of the point operation. Slides are independent for each switch and moves along with the switch rails, that is 115 mm in broad gauge and 100 mm in meter gauge. These slides have one short and one wide notch, and because of the wide notch, these slides are common for both broad gauge and meter gauge. Point detection slides are used for closing and opening the detection and control contacts. Point detector slides have one short and one long notch. The long notch facilitates the slides to use both in meter gauge and broad gauge switches. Brass strips are also provided in between them to prevent joint movement due to rust or friction. At one end of the slide, a threaded rod is riveted and welded, in which ground connection rod is connected by using a lug for easy adjustment of the notches to the requirements. The idle movement of the slide is limited to 3 mm and 53 mm in short and long notch when the roller B inside the detection contact assembly drops in the notches. Out switch. This is mounted on the motor at commutator side. It cuts off the power supply to the motor before insertion of crank handle for manual operation of machine. It makes the flap to give an opening for insertion of crank handle. To manually operate the point in case of failure or when power supply is not available, a crank handle has been provided. The procedure for hand cranking the machine is as given below. With the help of cover key, make an opening for insertion of crank handle key into the voltage cutoff switch. Insertion and operation of crank handle key cuts off electric feed to the point motor and makes an opening for insertion of crank handle. Now, with the help of crank handle, motor shaft can be directly moved, setting the point to any side. For power operation, crank handle is removed and steps 2 and 1 are followed in reverse sequence. Detection and control contacts. 2 sets of heavy-duty self-wiping contacts are provided for electrically detecting the normal and reverse position of the point and to control motor feed. The entire assembly along with its mechanism is named as switch and contact pedestal. The control contacts are named as normal control contacts and reverse control contacts. The normal control contact opens only when the point is set and locked in normal position. Similarly, the reverse control contact opens only when the point is set and locked in reverse position. For detecting the point switches in normal or in reverse position, 2 sets of contacts are provided. The respective contacts will be allowed to make only if the point is fully set and locked in the respective position and not otherwise. The entire mechanism is named as detection and control contact pedestal and arranged in such a way that only one set of contact is allowed to make at a time provided. The transmission assembly rotation is completed and both detection slides have completed its predetermined linear motion 100 mm in meter gauge and 115 mm in broad gauge. All these contacts are actuated only by the lift-out disc at the beginning of the operation and held in position by the control disc, which is usually roller B falling in detection slide notches at the end of the operation. The IRS point machine operates a point from normal to reverse and reverse to normal position. In this topic, you will learn about working of point machines electrically and with crank handle. Prerequisites for point operation. A point is operated by a point machine under the following conditions: when the point zone track is not occupied, when no signal is given leading over a point, when the crank handle is not inserted in the point machine, and when operation is authorized. Initial condition for point operation. To operate a point with a point machine from normal to reverse, the initial conditions are: point in normal position, reverse control contact is made, normal detection contact should be made, normal lock detection controller is in the notch on control disk. Sequence of point operations. The point operation from normal to reverse follows the below sequences: opening of detection contacts, unlocking of points, operation of points, locking of points, closing of detection contacts. Detection contacts are made when the roller is in notches of both control disk as well as lift out disk. Motor rotation starts. Main gear rim along with friction clutch gets its movement, which causes friction clutch spring locking plate to engage with lift out disk. The movement of the lift out disk lifts the roller A, even though control disk notch does not move as yet. This causes the opening of detection contacts. Motor rotation continues further after operating of detection contacts. Locking segment starts to move out of locking notches. Normal detection notch of control disk will now be shifted from its normal position, and roller A will rest on both lift out disk as well as control disk periphery. Roller B moves out of the normal notch because the detection slide locking segment is out of locking notches. Rack pinion engages with throw bar rack. Point moves from normal to reverse. Tongue rail flushes with the stock rail for reverse setting of the point. Throw complete. Moves into the reverse locking notch. Point detection slides are now in reverse position. Roller A falls into the notch in control disk and roller B into the detection slide notches for reverse setting. Reverse detection contacts made. Reverse control contacts break. During unlocking, both normal control contacts NC and reverse control contacts RC are made to facilitate mid-stroke operation. Of a point from reverse to normal is exactly opposite to the sequence of operation of points from normal to reverse. crank handle facilitates operation of points when track circuit fails, or track circuit fails, or the point cannot be operated from the place of operation due to any other reason, or for maintenance, adjustments and testing purposes. The crank handle control cutoff contact breaks when the CH key is inserted. The displacement of flap and the insertion of CH key and the rotation of handle from normal to reverse and from reverse to normal and the movement indicate clockwise and anti-clockwise direction. Driving slide. To adjust a point, operate a point machine with crank handle. Set throw bar connection and hand crank the point machine to normal position for the closed switch and position the locking slides to allow the locking dog to pass through locking slide notches. Adjust the closed switch to just in contact with the stock rail. Then tighten the connections further by 2 mm to 3.5 mm to impart a springing action to the tongue rail. Then hand crank the point machine to the opposite end of the stroke and repeat the setting for the other switch. Case 1. Incorrect settings. If the travel of drive rod is not correct, then either the tongue rail does not close at stock rail or the point machine does not operate due to continuous slipping of switch. At this juncture, adjust the setting of switch rail to normal position by tightening or loosening the nuts of drive rod to ensure correct setting point. Case 2. Correct settings. If the travel of the drive rod is correct, the tongue closes well against the stock rail at the end of operation. Lock slide. Connect lock slide and hand crank point machine to one end of the stroke. Position the locking blades and allow the appropriate locking dog to pass through notches. Hand crank the point machine to the opposite end of the stroke and repeat the settings for the other switch. Adjust detector rod near end and detector rod far end to make the detection notches align in line with detection rollers. Detection contact. Hand crank point machine to close tongue rail at one end of the stroke. Click the items on the menu bar to see the testing with 1.6 mm and 3.25 mm obstructions. Test with 1.6 mm obstruction. Insert 1.6 mm test piece between stock rail and switch rail at 150 mm from toe of the switch and operate the point. Detector contacts just make. Test with 3.25 mm obstruction. Insert 3.25 mm test piece between stock rail and switch rail at 150 mm from toe of the switch and operate the point. Adjust the detector connection of the closed switch till the appropriate detector contact breaks. Repeat the same at the other end of the stroke. Tighten all the relevant nuts. Friction clutch. For rotary type point machine, no attempt should be made to adjust friction clutch at site. Friction clutch can only be adjusted in authorized workshop. When difference between normal operating current and operating current under obstruction is less than 0.5 ampere, the clutch requires adjustment. Such a machine should be replaced. Ensure the correct setting of gauge in point zone at the following locations: 305 mm in advance of the tip of tongue rail, 152 mm inside tip of tongue rail on straight track and turnout track, at the middle of the tongue rail on straight track and turnout track, at heel of tongue rail for straight track and turnout track. Opening of switch. Ensure correct opening between stock rail and tongue rail on both sides. Williams stretcher bar. Ensure the provisions of Williams stretcher bar at 470 mm from toe of tongue rail with extended lengths below stock rails. Ensure the provisions of insulation for Williams stretcher bar and following stretcher bars. Clearance between stock rail and Williams stretcher bar. Clearance between bottom of stock rail and top of Williams stretcher bar should be 1.5 mm to 1.75 mm. Long sleepers. Ensure the provision of two long sleepers, that is, sleeper number 3 and 4 from stock rail joint. The extra length of the long sleeper should be on that side where the tongue rail is normally closed, that is, for normal setting side. Spacing between sleeper. Ensure correct spacing of 685 mm center between sleeper number 3 and 4 on which the point machine is to be mounted. Insulated gauge tie plate. Ensure the provision of insulated gauge tie plate on sleeper number 3 for wooden and pre-stressed concrete sleepers. Extension tie plate. Ensure provision of extension tie plate on sleeper number 3 and another iron plate for sleeper number 4 on pre-stressed concrete sleeper for point machine fixing. Creep anchor. Ensure provision of creep indicator and creep anchors in point zone. Point alignment 1. Ensure correct level and alignment of point. Point alignment 2. Ensure proper fitting of slide chairs. Points must be in perfect square, including sleepers. Measure the distance of tongue rail from stock rail joint of respective stock rails. It must be equal. Where necessary, creep anchors shall be provided between stock rail and tongue rail. Point alignment 4. Ensure correct housing of tongue rail with stock rail, at least up to 6 sleepers. Point alignment 5. For fixed heel, ensure the tongue rail should ply equally on both sides and should have equal tension on both sides, and it should lie in the middle. Point alignment 6. Ensure correct matching of left hand and right hand stock rails and tongue rails. IRS point machine is to be installed with ground connections on layout as per RD. Derailing switch. Stopper must be provided at free end on leading stretcher bar for derailing switch point to limit the travel of open tongue of tongue rail. Ballast. Ensure the point is fully ballasted and well packed. GFN liners and rubber pads. For pre-stressed concrete layout, ensure provision of glass-filled nylon liners and rubber pads. Insulated block joints. Ensure provision of insulated block joints or glued joints as per requirement for track circuits. Drainage systems. Ensure the provision of proper drainage system to prevent waterlogging in point zone. IRS point machine is to be installed with ground connections on layout as per RDSO drawing number S326263. Install the point machine at that side where the tongue rail is normally closed, that is, in normal setting of point. Point machine is installed by using following ground connections. P bracket or switch extension bracket, drive lug, drive rod or throw rod, lock rod long, lock rod short, detection rod long, detection rod short. P bracket or switch extension bracket is assembled on right hand and left hand switch rails with proper insulation. RDSO drawing number of P bracket is S3264. Drive lug is attached to the stretcher bar holes with insulation plate, washers and sleeves. RDSO drawing number of drive lug is S8806. Throw rod connects throw slide of point machine and drive lug. RDSO drawing number of throw rod is S8804. Lock rod long connects lock slide of point machine and P bracket. RDSO drawing number S327172. Lock rod short connects lock slide of point machine and P bracket. RDSO drawing number of lock rod is S3273, 3277, 3269 and 70. Detection rod short connects detection slide and P bracket. RDSO drawing number of detection rod short is S3269 and 70. Detection rod long connects detection slide of point machine and P bracket far end. RDSO drawing number of detection rod long is S3276 and 6. Drive lug is fixed on the leading Williams stretcher bar using two special nuts and bolts of 20 mm diameter as per RDSO drawing number SA312/M. Make two holes of 20 mm diameter for a new tongue rail for fixing P bracket at height of 67 mm for 52 kg rail and at height of 76.25 mm for 60 kg measured from the bottom of the tongue rail. Fix P bracket with insulations to both the left hand and right hand tongue rail using special thin head bolts and nuts of 20 mm diameter as per RDSO drawing number SA312/M. Keep both the tongue rails in center position. Installation procedure for point machine. Place point machine at a distance of 1050 mm from center of point machine to the edge of gauge face on sleepers number 3 and 4. Align point machine at right angles with respect to throw rod. Ensure crank handle side of point machine is on toe of tongue rail. Hand crank the point machine to keep throw bar in mid position. Connect throw rod to drive bar of point machine with drive lug in mid position of threading of throw rod. Connect throw rod to throw lug and check for equal throw on both sides. Adjust the drive rod by turning the nuts to ensure correct housing of tongue rails with respect to stock rails. Connect lock rod far end to lock slide and P bracket. Connect lock rod near end to lock slide and P bracket. Connect detector rod near end to detector slide and P bracket. Connect detector rod far end to detector slide and P bracket. Ensure all nuts and bolts are tightened. All split pins used with MS pins for connecting ground connections are splitted properly. Crank handle point machine to ensure free and proper movement on both sides. Let us summarize what we have learned in the installation of a point machine. Ensure the following from permanent way department before installing of point machine: correct setting of gauge, correct opening between switch rail and tongue rail, provision of Williams stretcher bar, provision of insulation for Williams stretcher bar, clearance between stock rail and WSB, provision of two long sleepers, that is third and the fourth. Ensure correct spacing between the third and fourth sleepers. Ensure provision of insulated gauge tie plate on sleeper number 3. Ensure provision of extension tie plate on sleeper number 3 and iron plate on sleeper number 4. Ensure provision of creep anchors and indicators. Ensure correct alignment of point. Ensure provision of ballast, GFN liners and rubber pads, insulated block joints and drainage systems. Install the point machine with ground connections on layout as per RDSO drawing numbers. Install the point machine at that side where the tongue rail is normally closed, that is, in normal setting of point. Provide ground connections as per standard measurements and RDSO drawings and with required insulations. P bracket or switch extension bracket, drive lug, drive rod or throw rod, lock rod long, lock rod short, detection rod long, detection rod short. Identify the parts of ground connections. The text box at the bottom highlights name of the part. To identify the highlighted part, move the mouse over ground connections and click the correct part. Repeat the above process until you identify all the parts. Ensure all nuts and bolts are tight and split pins are opened properly. Wire connections. Ensure wire connections of the machine are tight and laced properly. Ensure locking segment enters freely into the notches on the lock slides and with a little pressure in the notch of drive rod. Rodding connection. Ensure the rodding connections are tight. Fittings. Ensure point machine fittings are tight. Commutator. Ensure carbon brushes are exerting sufficient pressure on commutator. Clean the commutator properly using chamois leather piece. Parts. Ensure all moving parts are free from dust and are well lubricated. Rollers. Ensure that the roller rolls freely on the periphery of the control and lift out disc. Contact assembly. Check that the contact pressure of control and detection contact is adequate.
स्टॉप करो हल्लू कर
Ensure that gauge tie plate, Williams stretchers and P brackets are properly insulated. These connections are properly tightened. Ensure that the normal working voltage are within specified limits. Ensure that the normal working current and slipping current are within specified limit. Point machine. At the time of installation and after every 6 months, pour lubricating oil SAE 30 or Shell 100 through the inlet into the oil reservoir for lubricating gearbox of the motor. The period may be decided according to the local conditions. Pour the SAE 30 on the periphery of control and lift out disc and felt pad provided over the drive rod and the lock slides. To lubricate the spring guide in the contact unit, apply 5 drops of spindle oil on the helical spring guide of contact assembly. Ensure that no excessive lubricating oil or water accumulates at the bottom of the point machine casting. Greasing nipples. Apply non-corrosive all-temperature grease as per specification IS 507 or 508 through all the 10 grease nipples by a grease gun once in 6 months or as per local conditions. 6 grease nipples are provided to lubricate the bearings of the drive rod, lock slides and detection slides. 2 grease nipples are provided on transmission assembly. 2 grease nipples are provided on contact unit. Apply the same grease on the main gear and its pinion and rack and pinion teeth. Check the condition of the sleeper, tongue rails, leading and following stretchers and their fittings. Permanent wave fittings. Check the permanent wave fittings: stock rail, setting of switch rail with stock rail, packing of point zone, gauge, gauge tie plate, and point squareness. Heels. Check that loose heel and fixed heel switch joints are proper. Water logging. Check that water does not stagnate in the vicinity of points. Ensure that there is no rail creep in the vicinity of point zone, panel rails. Such type of creep arrangements are provided with creep indicator. Here, obstruction to lock side. Reason: lock pawl not entering into the notch of lock slide. Remedy: check the setting and housing of switches, engineering gauge, MS pin, creeping, tightness of every connection. Failure: lateral movement of point. Reason: loose packing, absence of rail pegs, long bolt or slide chair nut bolts may be loose. Remedy: ensure proper packing, provision of rail pegs, change decayed sleepers, tighten chair plate and long bolt nuts. Failure: motor operating but point switches not operating. Reason: due to lack of lubrication of slide chair or friction clutch may be loose. Remedy: lubricate the slide chairs properly. Adjust the friction clutch. Check and adjust the transmission assembly. Failure: motor not operating. Reason: due to fuse blown off or breakage of wire connection or carbon brush disconnection or carbonization of commutator, disconnection of control contacts, CHC contact not making. Remedy: if control relays are pickup, change fuse of power rating. Check intactness of wires in JV and inside point machine. Check carbon brush holder. Clean commutator. Adjust control and CHC contacts and clean it properly. Failure: detection contact not making. Reason: roller may not fall inside detection slide notches. Remedy: check and adjust detector slides, then check detection contacts. Failure: point not operating fully. Reason: when point gets creep due to rails moving forward or backward, point operation is not proper. Point will not set fully. The ground connection will rub against face of the sleeper and cause high pressure on point machine, due to which friction clutch will slip. Remedy: observe the condition at point and arrange with permanent way staff to rectify and to arrest creep on point. Failure: motor not operating fully. Reason: when switch rail is above chair plates, creating a gap between bottom of the switch rail and top of the chair plates, it is understood that the point has sunk. Since switch rail is floating and not sliding on chair plates, the point operation will be harder, causing pressure on point machine, due to which the friction clutch will be slipping. Remedy: observe the point condition and arrange with permanent way staff to lift the point zone and packing to be done properly. Note: due to loose soil, loose packing or water logging at point zone, the sinking of points may also occur. Do's and don'ts in troubleshooting. Do always take out concerned crank handle with you during disconnection. Do always use proper rating of fuse. Don't forget to test the point after any work. Don't attend the point failure without proper disconnection. Don't use too much lubricant. Don't forget to check the correspondence of actual position of point with point indication after replacing machine or cable measuring or testing of track locking. Don't allow the crank handle to remain in the crank handle box while working on point during disconnection. Don't try to replace any part of the point machine or associated wiring without proper disconnection notice. Don't commence maintenance work without telecommunication with on-duty ASM or CSM. Obstruction test. For obstruction 5 mm. Place an obstruction test piece of 5 mm between stock rail and tongue rail at 150 mm from the toe of switch and ensure that friction clutch declutches the motor from mechanism. Lock segment does not enter into the notches of locking slides and point driving slide. Roller of the lock detection lies on the periphery of control disc. Switch detection contacts do not make. The friction clutch shall slip at a value not less than 1.5 and not exceeding twice the normal working current. Obstruction test for obstruction 1.6 mm. Place the obstruction test piece of 1.6 mm at 150 mm from the toe of the switch rail. The machine should get locked and detection contacts should be made. In a closed track circuit of point zone, operate the point by dropping the track relay. Point should not operate from normal position to reverse position and vice versa. Pick up the track relay and operate the point. Point should operate from normal to reverse and reverse to normal. Check insulation of point cables with 500 volt mega once in 6 months. Correspondence testing must be done after measuring. All conductors in signaling cables must be tested for their insulation in dry weather every year as per instructions. A comparison of the test results between successive tests carried out on a cable under similar conditions will give an indication of the trend towards deterioration of the insulating material over a period of time. If a sudden fail in insulation is observed, the cause should be investigated and immediate steps should be taken to repair or replace the cable. In addition to the regular testing of cables in dry weather, random tests in wet weather may also be carried out where considered necessary to localize any sudden deterioration in insulation of cables.